Hello everyone, good morning. Welcome to the live lecture of Doubtnut. So, today we are gonna do chemical reactions of haloalkanes and haloarenes. We were doing the chapter haloalkanes and haloarenes. So, today we'll start with the chemical reactions of haloalkanes. We have already completed the preparation methods of haloalkanes, preparation methods of haloarenes. We have discussed the physical properties of haloalkanes, right? So, today a new topic is being started, that is the chemical reactions of haloalkane, and it is really interesting, right? So let's start. If you don't know me, let me introduce myself to you. My name is Shagun and I've done my masters in chemistry from Random Delhi University. I've had few qualifications. If you want to give a look to it, you can, otherwise we can skip this portion. So today, as we know, we have already completed. I'll give a quick revision of what we have completed. If you have missed any of the topic, you can go and check out at that particular topic. The videos are available on Doubtnut app as well as YouTube app, right? So we have completed the preparation methods of haloalkanes, prep of haloalkanes, also commonly known as alkyl halide. Then we did the physical properties of haloalkane, physical properties of haloalkanes, in which we have discussed the boiling points, melting points, density, your solubility. Everything was discussed in quite detail with all the previous year solutions and questions we have done. Boiling point, melting point, density and solubility we have discussed. Everything in the physical properties of haloalkanes. And then in the last class we've completed the preparation methods of haloarenes. Now we are left with just two more topics, that is the chemical reactions of haloalkane, which we'll start today, right? We'll start the preparation methods of haloalkane, and we'll also practice the NCERT questions, the in-text questions, as well as back exercise questions will be practiced, and we'll also discuss the previous year questions today. Before we start, let's hear some announcements. A quick announcement is that Doubtnut is organizing a scholarship test on 18th July, which is Sunday. The coming Sunday, you have a scholarship test, and those who are studying in class 6th to 12th can participate, as well as students preparing for IIT-JEE and NEET can also participate. You have the opportunity to grab the scholarship about 1 crore, and you have to register. To register, every detail is sent to you through the comment section. You can check that out. Also, those who is participating in this Doubtnut scholarship test gets 10% discount on every course he or she likes to purchase, right? Every participants get 10% discount, and the one who wins this scholarship test will get 100% scholarship about 1 crore, right? The result of this test will be announced on Sunday itself at 6 p.m. So hurry up and register for your scholarship test. Also, there is a good news. Doubtnut is organizing or has launched an English speaking course. English speaking course will be taken by our top teachers. The course has been already started from 8th July. To know more, check your comment box. And Doubtnut is also starting a new batch for class 12th students. You only have to download Doubtnut app, and there you can see the live lectures. Also, you can see the recorded lectures. After every class, you'll get homework, and weekly we have your test. We'll conduct your test. We have books available for you, and also NCERT solutions are available. We follow proper timetable, and notes, teachers notes will be provided to you, and there will also be ways to that guides you in a proper manner, right? The best thing about this course is our top teachers are taking this course. They have best results, and there will be also doubt clearing sessions. They are your teachers. They are physics teachers, chemistry teachers, bio teachers, maths teachers and English teachers. Their videos are available on Doubtnut app as well as your YouTube app. You can check that out. The best result of Doubtnut is Harsh Kumar scored 91% in class 12th, and he was a district topper, Aurangabad, Bihar. Similarly, Shreya Ishani, who scored 91% in class 12th, district topper East Champaran, Bihar, and we have more than 100 students who have scored more than 85 marks, right? Doubtnut is one of the best institute in doubt solving. How your doubts get solved? We give you homework, we make notes for you, we have tests for you, and all the questions given to you in this process have video solutions available for you. You can clarify maximum doubts from here. Also, you can watch the classes at live classes, or if you want to see the recorded lectures, these are all that they are also available. To clarify your doubt, what you have to do is just download Doubtnut app, click a picture of your question, and find the solution on Doubtnut app. Also, you can leave your doubts on in the comment section. Respective teacher will answer your doubt, and you will be notified that your particular teacher has clarified your doubt. You can go and check out the doubts you have. Text solution as well as video solutions are available on Doubtnut app. You can easily check that out. Also, if you want to know anything else about, or if you have any inquiry or problem, you can call at 0124758250 or comment in comment section. Now, can you please let me know whether you are interested in joining class 12 board exams or not? Whatever is your answer, please answer through the poll that is popping up in front of you. Okay, so let's start. Haloalkanes and haloarenes. We have completed almost all the preparation. Before we start or move into the new topic, let's do some question practice. So this is the question from your in-text NCERT book. You have to tell me the answers of all the parts, right? We have 6 parts in it. You have to tell me answers of each and every part. I'm giving you a minute. Start the answers. Start writing the answers in the comment section, and then we'll discuss with the complete detailed solution, right? Okay, so I'll wait for a minute. You can start it. See, revision is one of the most important thing to happen. If you are moving ahead, you make sure that you learn and keep revising the previous content too, because if you are not revising the previous questions or previous lectures, that will create a problem, because at the end a burden will be created and you'll leave that chapter. We have completed everything, so you have to continue, and before you enter into the new class, make sure you revise the whole chapter, whatever has been done up till now, right? So let's start with the questions. So this is your cyclohexanol. This is your cyclohexanol, and it is being reacted with SOCl2. This process was known as Darjan process. As we know, Darjan process is one of the best process to, or one of the best method to prepare haloalkanes from your alcohols, because the byproducts of your Darjan process or method is SO2 and HCl. They both are in the gaseous form. You do not need anything else to separate the byproduct, and it is very cost effective. They itself gets separated, right? So when alcohol group is there, you treat it with SOCl2. The major product you get is chloro cyclohexane. It is chlorocyclohexane, and SO2 and HCl is being removed, or they are the byproducts, they get removed. This is the main product you get, right? So the main product is your chlorocyclohexane. Then the second reaction, in the second part, you treat this with Br2 heat or UV light. I have already explained to you that whenever UV light is mentioned, what you have to remember is form the radical. Br2 undergoes homolytic cleavage to form Br-Br radical, and this reaction happens by a free radical mechanism. You have to also create a free radical in your substrate, and as you know, the secondary free radical is more stable than the primary free radical. So here, if we form a radical, this will be a secondary radical, and here if a radical is formed, it will be a 1-degree radical which is less stable, and this is secondary radical as well as this is stabilized by resonance. We have already discussed this. If you have revised, you will face no problems. This is NO2, this is CH radical which will be formed, and we have CH3 here. Br radical reacts with it, and the main product you get is, I'm just writing the main products, is this CH, this is Br, and the fourth position has NO2, because if I consider this 1, 2, 3, 4, now I have shifted the carbon here. This is 1, 2, 3, and this is 4. Fourth position will be NO2. So this is the major product you get in second part. Okay, so let's move to the third part. In third part, what is happening is you are reacting an alcohol with HCl. Now we have two OH group. We have a OH group which is attached to the carbon, and that is not a carbon of a benzene ring or a phenyl ring, and one OH is attached directly to a phenyl ring or a benzene ring, right? So which of the OH gets replaced? Is the first OH that gets replaced, or it is the second OH that gets replaced? You must remember that the mechanism for this was the HCl acts as acid. It is a source of H positive ions. Oxygen has lone pair, donates its lone pair to H positive ions, and lone pair is donated by oxygen. It develops a positive charge, and a new bond between oxygen and hydrogen is formed, right? Now this acts as a very good leaving group because water as a neutral leaving group is removed, and your carbocation is formed. CH2 positive is formed, and we have this. Now Cl minus reacts with it, and finally the product of the third part becomes this. It is CH2Cl. Why did this OH didn't react? Because if you protonate this OH2 positive is formed. If this is removed, a carbocation is formed on sp2 hybridized carbon. A carbocation is formed on sp2 hybridized carbon, and sp2 hybridized carbon is itself electron deficient. The carbocation stability is very less on sp2 hybridized carbon. So sp3 carbocation which is formed is more stable than sp2 carbocation. Hence the OH which is attached to the carbon, that is not the benzene carbon, gets eliminated, and Cl replaces it. The final product formed here is this. Moreover, we can also explain the reaction in this way. Whenever you treat phenol with your HCl, the reaction to form chlorobenzene is highly difficult. Reason being, oxygen has lone pair, it is in resonance with benzene ring, it develops a partial polarity between carbon and oxygen. The partial double bond is a stronger bond in comparison to the single bond. Because of the partial double bond, the bond is stronger, and Cl minus, it's very difficult for water molecule to be removed, because water molecule now is connected due to resonance. It is connected to your benzene ring, and it is partially double bond. It is not easily removed the way it was easily removed in this case, right? So this is the reason why your phenol or your aromatic alcohols does not undergo your substitution reaction quite easily, because they develop partial double bond character. Okay. Now let's move to the part 4. This is normal addition of HI. We follow Markovnikov rule, right? Markovnikov rule is followed. This is double bond, it has no hydrogen, it has one hydrogen here because three bonds are already formed. The fourth bond will be with the hydrogen, and according to Markovnikov rule, as we know, rich becomes richer, right? So hydrogen gets more hydrogen, the carbon with more hydrogen gets hydrogen, and the final answer is this. Right? So iodine gets attached to the carbon which has methyl group because it has less number of hydrogens there. This is hydrogen. Hydrogen gets from Hi, the hydrogen gets attached here, and iodide, I minus, gets attached here. So this is the major product of food part. In the fifth part, NaI, I minus attacks carbon delta positive, removes Br in delta minus form, I minus attacks, Br minus is removed. This is your Finkelstein reaction. So the major product is CH3CH2I, and Br minus is being released, right? Okay, so in the last part again you have what? A free radical mechanism will be formed just the way in the second part you were using UV light. Here also we are using UV light, and UV light leads to the formation of a free radical. Br radical is being formed here, and you must know how to form the radical in the substrate. That is the most stable radical will be formed in a substrate too, where Br will attach itself to, right? So this radical, which radical, when Br radical is formed, Br2 breaks down into two Br radical. One of the Br radical reacts with this substrate. And a new free radical is being formed on the substrate to form, and HBr is released. One Br radical is still left. Now question is, why is this free radical formed? You must remember that this free radical is in resonance with this free radical. If I draw this here, this free radical is in resonance. This free radical is in resonance with the double bond. Hence, delocalization of electron leads to the formation of stability of a radical. This radical formed here is very stable. This is known as allylic radical which is just adjacent to the double bond. Allylic radicals are stable because they are in the resonance with the double bond. So stable radical is formed here. Br radical, the left Br radical attaches itself to this radical and forms this as a major product. So this is the major product of your sixth part. So this was the in-text questions which we have finished. Now we'll start with the chemical reactions. I'll give you a quick overview of how does chemical reactions looks like in organic chemistry. So if we consider a chemical reaction in organic chemistry, it is generally represented as substrate plus reagent. It is generally represented as substrate plus reagent in solvent conditions. In solvent, you have to use or dissolve substrate and reagent in a solvent, and if there is any pressure temperature condition, please mention that too. You get final product, and if you have byproducts or leaving group, you can write that too. So this is the general representation of what? This is the general representation of your organic chemistry chemical reactions. The chemical reactions of organic chemistry are generally represented in this manner. Now what is substrate and what is reagent, what is solvent, what is product, what type of product you get, we'll discuss everything here. A reagent is something that attacks the substrate, right? A reagent is attacking species. A reagent is attacking species. A reagent is attacking species. Somebody who attacks substrate is your reagent. For example, if I take we can take R minus MgX, right? CO2. If you consider this, here the attacking species is R minus, who attacks carbon delta positive. Oxygen being more electronegative takes the pi electrons as well as sigma electrons towards it, develops partial negative charge. Carbon is less electronegative than oxygen atom. It develops partial positive charge. R minus delta positive attracts towards each other. R minus attacks carbon. So attacking species and breaks one of the pi bond, oxygen minus is being formed. RCO minus is being formed. So this is the one which attacks. Attacking species is your reagent. Attacking species is your reagent. And this one who is being attacked at, or who is being attacked at, is your substrate. So this is your attacking species. The substrate is the one who is being attacked, by attacking species or your reagent, right? So CO2 is being attacked by a reagent which is R minus, and CO2 acts as a substrate here. Now the role of the solvent here is to maximize the yield. You can write the solvent is used to increase the percentage yield. Increase the percentage yield or amount of product. What is yield? Yield is how much product, the quantity of product which is being formed. If 1 mole of substrate reacts with 1 mole of a reagent, you suppose in a reaction 1 mole of a substrate reacts with 1 mole of a reagent to give you 1 mole of product. But sometimes you do not get exact 1 mole of product. You might get 0.5, 0.6 or 0.2 depending upon how much effectiveness a reaction is being is at, right? So more the effectiveness, more the reaction between substrate and reagent, more will be the collisions, more will be the bond breaking, more will be the bond formation, more will be the percentage yield. Solvent helps to homogenize the solution of the substrate and reagent. It increases the interactiveness between substrate and reagent and hence increases the percentage amount, or it is said as percentage yield of your product, right? And we'll also discuss about leaving group. This is especially in haloalkanes. This is specially discussed in chapter haloalkanes. So this was quite overview. Also you must know that substrate and reagent, the reaction proceeds like in the first step, substrate and reagent attracts towards each other. Substrate and reagent are of opposite nature. They come closer, they attract towards each other, the old bonds are broken, collision happens and the old bonds are broken and the new bonds are formed. I'll give you one example. The simple example is like if I consider this RMgX and reaction with a CO2. R is negatively charged, carbon is delta positive. Positive and negative, as you know, they all attract towards each other. Opposite charges attract towards each other. This reagent is attracted to the substrate. The reagent will go towards the substrate. More collisions will happen between your substrate and reagent. The old bonds are broken and the new bonds are formed. In this case, the old bond is between carbon, the pi bond between one of the carbon and oxygen. This is the old bond which is broken. The old bond is broken. So this was the old bond which has been broken and a new bond between R and carbon is formed. So this is the new bond which is formed. So after collision, why collision is happening? Because of the attraction between substrate and a reagent. They are coming together, they are colliding with each other, energy is being released, old bonds are broken, new bonds are formed and new bonds are formed. Finally, when this process happens, you say a new product are formed. A new products or product is formed, right? So this is the way your organic chemistry chemical reactions happens. And if we discuss about little more about substrates are of two types. They are electron rich substrate. We have electron rich substrate And we also have electron deficient substrate. In electron rich substrate, you have generally pi bonds including in it. Pi bonds are weak bonds. They have loosely held pi electrons. They have loosely held pi electrons. The electron rich substrate have pi bonds extra within the molecule, and pi bonds are weak bonds. They have loosely held pi electrons, and then we say they are electron rich. We say because electrons are loosely held, they are, like we say, they are electron rich species. They are electron rich substrate. For example, it is your alkene, that is electron rich substrate. Your alkyne, they are also your electron rich substrates. Benzene, electron rich substrate. Your naphthalene, pyridine, everything which has pi bonds and excess of electron density are your electron rich substrates. Right? We can also take naphthalene, anthracene, and whatever. These are your electron rich substrate because you see pi bonds within them, right? We also have electron deficient substrates. The electron deficient substrates usually have delta positive or positive charge on it. They are electron deficient. They are having positive or delta positive charge on it. For example, Rx, your haloalkane. Halogen atom is more electronegative than carbon atom. It takes away the sigma electron towards it via inductive effect, develops X. X develops partial negative charge. Delta positive charge is developed on your alkyl part. This is the electron deficient part of your substrate. Anything whenever you see R positive or R delta positive, they act as your electron deficient substrate or electron deficient part of the substrate, right? If we see carbocation, they are also your electron deficient substrate. This is also your electron deficient substrate, right? So this is your substrates which can be classified as electron rich substrate. Electron rich substrates have pi bond with them. Electron deficient substrates have delta positive or your positive charge on it. We'll discuss little about reagent also. Reagent can also be classified in two parts. Reagent 2 can be electron rich. Reagent 2 can be electron rich as well as electron deficient. If we consider electron rich reagents, they are commonly called as nucleophiles. Electron rich reagents are called nucleophiles. Now nucleophiles are of two types. They can be neutral, they can be charged. They can be neutral, they can be negative charge. Because they are electron rich, either they are neutral by having excess of lone pairs, they have lone pairs on it. That is why we say they are electron rich. They also are negatively charged species. If we consider neutral nucleophiles, we have the examples of water. Because oxygen has two lone pair, we also have ammonia. We have RNH2. They all are the nucleophiles. They all are the reacting species, attacking species which are neutral and they have excess of electron density, hence they are nucleophile. Negatively charged nucleophiles are your OH minus because they have it has negative charge, negative. RO minus, NH2 minus, they are all your negatively charged nucleophiles. Why I am discussing it, I'll I'll tell you in that in some time, but just write whatever I am writing in your notebook. I'll clarify and I'll give you a quick summary of what we have learned today. Okay, so the first part of the reagent was electron rich and the second part is electron deficient reagent. Electron deficient reagent is commonly known as electrophile. Electron deficient reagent is commonly known as electrophile. Right? So electrophiles can also be classified in two parts. One is neutral electrophile. Another one is electron deficient or positively charged electrophiles. Since it is electron deficient, it is neutral or it can be positively charged. In neutral, we have examples of BF3, AlCl3. They are neutral electrophiles. Why is BF3 electron deficient? As you know, every atom, every center atom, or every atom wants to complete their octet. Since if you consider fluorine have 3 lone pairs and 1 BF bond, the octets of fluorines are fluorine atoms in BF3 is completed. But if you consider the octet of B here in this case, it is not completed. The octet of B in BF3 is not completed because it only has 3 sigma bonds, and every bond, as we know, is made up of 2 electrons, implies that it only has 3 into 2, that is 6 sigma electrons. They have 6 sigma electrons, and boron atom's octet is not complete. It is 6 electron species. Octet is not complete. It is electron deficient, hence it is electrophile. And also positively charged electrophiles are your normal R positive. If it attacks, it acts as a positively charged electrophiles, right? We have RCO positive, acyl radical, they will be commonly seen in Friedel-Crafts reactions. We'll see the formation of electrophiles in Friedel-Crafts alkylation and Friedel-Crafts acylation. Right? So this was your substrate and reagent. Now you have to listen to me very carefully. I already have explained you that organic chemistry, you generally write that the reaction happens between substrate and reagent. They attract towards each other, they collide with each other, and we use solvent. The product is being formed. Now substrate and reagent have to attract towards each other. They should be opposite nature. They should be of opposite nature, because they have to finally attract and collide with each other. They should be of opposite nature. That is, if I take substrate as electron rich, if I take substrate as electron rich, if I take substrate electron rich, what type of reagent will you use? Will you use electron rich reagent or electron deficient reagent? If substrate is electron rich, the reagent has to be of opposite nature. That is, you have to use electron deficient reagent, and electron deficient reagent, as we know, is commonly known as electrophile. So when we have substrates which are electron rich, the electron deficient reagent is used, that is electrophile is used. And whenever we use electrophile in a chemical reaction, they particularly shows electrophilic reaction. So they will show electrophilic reactions. I'm not talking about whether it is substitution or addition reaction, but since electrophile as a reagent is being used in a chemical reaction where the substrate is electron rich, the reaction would be electrophilic nature. If I say the substrate is electron deficient, and the reagent will be, then obviously the reagent will be electron rich, because they have to be opposite nature. An electron rich reagent is known as nucleophiles, and whenever a nucleophile is used in a chemical reaction, they will show nucleophilic reactions. Right? So in the case of your haloalkanes and haloarenes, the substrate is your haloalkane. In case of haloalkanes and haloarenes, if we talk about the chemical reactions of haloalkane, the substrate is your Rx. Right? This is your haloalkane. X being electronegative, it will have delta negative charge. This will has delta positive charge. No pi electron density. This substrate is electron deficient substrate. This substrate is electron deficient substrate. If in haloalkanes, in chemical reactions of haloalkanes, if the substrate is electron deficient, which will be the reagent type? Reagent has to be, obviously, in order to attract substrate and reagent towards each other, the reagent should be electron rich, because they have to be in opposite nature, right? So the reagent should be electron rich reagent. And electron rich reagent is commonly called as nucleophile, and I've already told you, whenever nucleophile participates in a chemical reaction, you'll usually observe nucleophilic reactions. So by this, whatever we have learned, we have understood that in haloalkane, in chemical reactions of haloalkane, in chemical reactions of haloalkane, chemical reactions of haloalkane, in chemical reactions of haloalkanes, since nucleophiles are used, nucleophile is used, the reaction type will be nucleophilic reaction. The reactions which will be commonly observed in chemical reactions of haloalkane will be of nature nucleophilic reactions, Now we can classify, or we can further divide nucleophilic reactions in two parts. One is SN1 mechanism, another one is SN2 mechanism. Also, we need to understand this is nucleophilic reaction, but we can further classify it as addition reaction or substitution reaction. You must remember that in Rx, which is the haloalkane, a nucleophile, which is the reagent, attracts carbon delta positive and it removes X minus. Because halogens are very good leaving group, R and nucleophile new bonds are formed. The old bond between R and X is removed, it is broken. So this is the product, and since X is the leaving group, it gets X minus, they are good leaving group, they are being replaced by nucleophile. Instead of X, now we have nucleophile. So this is your substitution reaction. In haloalkanes, we usually observe nucleophilic substitution reaction. It was nucleophilic because your substrate was electron deficient, and your nucleophile was being used because we have to use opposite nature substrate reagent of opposite nature to that of a substrate. Opposite nature substrate was your nucleophile, and nucleophile generally shows nucleophilic reactions. Since in haloalkane we have good leaving group, halogen acts as a they are the good leaving groups, they usually show substitution reaction. So we conclude that in haloalkanes and haloarenes we observe nucleophilic substitution reactions, and nucleophilic substitution reactions can further be classified as, they are commonly written as SN reactions. Nucleophilic substitution reaction or substitution nucleophile, they are written as this. SN is a short way to write nucleophilic substitution reactions. SN reactions can be further divided as SN1 or SN2. We'll further study about this reaction in tomorrow. This was an overview of how the reaction proceeds, what sort of reaction we observe in haloalkanes, right? I hope it's clear to you. We'll further continue this and we see how the nucleophilic substitution reaction proceeds in it. So today we have understood why haloalkanes only shows nucleophilic substitution reaction, why not electrophilic substitution, electrophilic addition or nucleophilic addition. So today was the basic introduction of what we have understood, that your haloalkanes usually undergo nucleophilic substitution reactions, and if we have discussed each and every point to it. We'll continue this topic in next class, and the next class will be the chemical reactions of haloalkane. I've given it in the form of parts, so this will be the part 2, and we'll take that class at 10:30 AM on Monday. Till then, thank you so much for watching and have a nice day.